Hello friends, welcome back to the YouTube channel. This is Rahul and today we are going to see what is CAN bus. Okay, so now we have made on this YouTube channel lots of 3D software commands, okay, regarding to 3D routing, 2D routing of the wire harnesses using Creo parametric software and Zuken softwares. So now today in this video we are going to some focus on technical things, just like what are the CAN cables and where they are used and application purposes, advantages and disadvantages of the CAN bus, how the construction of the CAN bus is there and what are the purposes over there, right? Okay, so let's get started. Those who are new on this channel, kindly subscribe the channel, because this type of information I have making on this presentation and some recording format on my YouTube channel only because of having some industrial skills and knowledge. Okay, so you don't have to pay anything for this, so please kindly subscribe the channel, it's my humble request. Now let's get started. So main question will arise in your mind, that is, what is the CAN bus, right? So I will just give some brief through this image. Okay, so we'll get a little idea about that CAN bus. Okay, so most of the here about CAN bus, it is the one type of cable which is used in some electrical appliances or somewhere, right, and having two wires inside that, right? So basically these CAN cables are used mostly in the automotive sector, like just like cars, trucks, right? So here you can see on this car model different units are mentioned here, just like as you can see my cursor here indicated engine control unit, right? So this here is the engine control unit, here is the power steering unit, here is HID and LED light, here diagnostic unit is present here, climate control devices are here, dashboard is here of the car, right, and keyless entry central locks are here, transmission control is there, connectivity is from here, TV model is there, right? So different features which cars have or we provide to car are categories here, right? And each and every device required to have a connection or to have a network for controlling in the car, right? So whenever you are going to do the wiring of your car, so what things you come in your mind, that is just like for LED light, this is the backside LED light, this will have two wire and it is going to connected somewhere here battery, for the battery. Oh, okay. And power steering sensors, for engine control sensors, each and every devices having two wires separately for power and for controls, right, in regular practice. And this is the old method. Okay, so previously we were using lots of mixture of this wire and very difficult connections over there, right? So it will cause the different problems, just like magnetic interference, because if there is lots of wires connected here and we are using different large functions. Okay, so first problem will occur just like magnetic interference, second will be short circuit, because large number of wire are there, so large short circuit will be there. Okay, and for identification of the wires it will be getting troubled, right? And the costing of the wire is also main factor which play here, because as large wire you use and the large costing will be there, right? So in this scenario they have developed the CAN bus cable, right? Main question, who invented this CAN bus cable? Okay, so the Robert Bosch, they have invented this cable first, right? So every devices are connected to each other, just like our human brains. Now in case of human brains, what he do, he control all the activity, he control our both the hands, both the legs, all activity what he wanted and what he think, right? So just like that, car have the ECU, electronic control device, okay, one main ECU, and it is connected to all sub ECUs. Just like this, the main ECU will be somewhere here, right? And what you can say, so it is connected to engine control, it is also connected to LED lighting, it is also connected to audio system. From the central point, it's what you can say, it's controlling all the activity of this, all the features, okay. And these are called as sub, we can say microcontrollers. They have microcontrollers and they are communicating this, all the features communicating with the single ECU, okay. Just like transmitting messages to each others, okay. Now we'll move to the next slide, okay. So yeah, actually this was just for the YouTube subscription. Just remind you, please subscribe the YouTube channel. Now next, yeah, here I have mentioned control area network. This is long form of the CAN bus. Is a serial communication protocol that allows devices to exchange data like sensor and data, okay. Just like every car have different sensor, camera sensor, radar sensor, or what you can say, for Bluetooth different features are there. So every device communicating with this ECU, so there must be a medium. So the medium is called as CAN bus, from ECU to different types of sensors, main device to other sensors, right? Now it is widely used in vehicle working like a nervous system, okay. Remove complex dedicated wiring. Just in old times, mostly use the complex wiring. By using CAN bus, why or how these wire are reduced, we'll see in the next construction of this CAN bus. So definitely we'll understand why I am telling you like that. Electronic control unit ECUs are like part of the body. Interconnected view CAN bus transformation sensed by one part can be shared with another, okay. Mean different, here is the main ECU control unit and that is connected to other sub ECU of the car, right? Now, so one question will arise, what is ECU now, okay. We'll move to the next slide. So ECU means automotive CAN bus system. ECU CAN, example, the engine control unit, airbags and audio systems, right? As I told you, ECU is a electronic control unit, right, which is used in the automotive cars. And if you can take example of an engine control unit, this is one of the sub ECU. And airbag, for airbag controlling, other sub ECU is used. For audio system, other sub ECU are used. Every feature has a sub ECU which controls these signals, right? Now next, up to the 70 ECUs, means every car have mostly more than 70 ECUs. As you increase their feature of the car, the according to that functioning, the ECU also goes on increasing, right? Now ECU can prepare and broadcast information. Prepare and broadcast information, sensor data, view the CAN bus consisting of two wire, CAN low and CAN high, okay. So CAN bus have only two wires, CAN high and CAN low wire, okay. Mean only two wires are used for transmitting all this data. Like just assume the 70 sub feature you are using in the car, so how many wire will require for each feature? Just take example, just for engine control unit you are using two wire, for airbag you are using two different wires, for audio system you are using two different wire, and which is directly connected to the ECU, right? So what they did, they are not using the large wires, they are using only single cable, okay, and using two wires, just like CAN low and CAN high, right? The broadcasted data is accessed by all other ECU on the CAN network. It means whatever the signal is passed from main ECU to other sub ECU or other sub ECU to main ECU, okay, this message is transferred through through ECU on the CAN network. And this main thing you will understand only by what we can say, only one example or having construction you will see in the next slides. Okay, and each ECU can then check the data and decide whether to receive or not, or ignore it. Okay, this sentence means from ECU the signal is passed, right? Now the main question, what the signal is. Okay, so if I wanted to open the door's glass, right, I have pressed the button. So what signal is sent from ECU? Open the door glasses, right? So ECU will send one signal to door lock, not to door lock actually. ECU will create one signal and pass throughout the cable, right? Just like assume 111 is the signal which ECU is passed, and 111 signal is assigned to only door glass opening unit. So that time this is signal is passed from ECU to throughout the cable and all the features. That time only door glass unit is going to accept that signal, because this 111 ID is only assigned to door glass, not other features. So other feature, what will do, other features will decline that signal which is received from the ECU. Okay, it will understand in detail and easy way in the next slides. Just go to the next slide. Now what is CAN ECU? Okay, now here you can see this is the actual construction of the CAN cable. Here I have attached one image just for understanding you. Here you can see one yellow and green wire is there, and the third wire is which is bare, which is called as shield wire, and which is mostly used the grounding purpose. So only two wires are there. Okay, which is CAN high, which and other is the CAN low. Now here you can see this is CAN high, this is the CAN high and CAN low cable. Okay, now first feature ECU1, ECU2, ECU3. Okay, so these are sub ECUs which are connected to this cable like this. Okay, prepare, send, accept, check and receive, accept, check, ignore. What it indicates? Now this ECU prepare and send means this ECU has sent some signal, right, that is accepted by ECU2 because the signal was for ECU, and in the ECU3 this signal is ignored. It means the signal was not for this ECU number 3. Okay, now go to the next. What is CAN bus physical and data link layer, OSI? CAN is described by data link layer and physical layer. Okay, means they described by data link layer and physical layer. Means in ISO 11898-1 describes the data link layer, means it describes the properties of data link layer, and ISO 11898-2 describe the physical layer properties. Now CAN is often presented in the 7-layer OSI model. The 7-layer OSI model is available in the next slide. CAN bus physical layer defines things like cable type, which type of cable is there, electrical signal level, node requirements, and cable impedance. These properties are belongs to this cable physical layer. Okay, now ISO 118, one second, yeah. Now ISO 11898-2 detects a number of things including below. Okay, so baud rate. CAN node must be connected view to wire bus with baud rate up to 1 MB per second. Okay, classical CAN or 5 MB per second. It means the cable should pass this 1 megabytes per second data. Okay, and the cable length, maximum CAN cable length should be between 500 meter. The length having CAN cable 500 meter can deliver 125 kilobytes per second data, and the length of cable having 40 millimeter length can transfer 1 megabytes of 1 megabytes per second data, right? And next, the termination, the CAN bus must be properly terminated using 120 ohm resistance CAN bus termination register at each end of the bus. Okay, so in this communication there is a frame, means this whole process start from a single frame which start the cycle and which end the cycle. So at the starting and at the ending there is a 120 ohm resistance. The diagram will show in the next slides, which is used because of reducing the some extra signals or to save the signal and to avoid the damages of the signals. Okay, now in the next window, what is CAN bus physical and data link layer? Okay, so this is the main layers of this CAN: application, presentation, session, transport, network, data link and physical. These are the main. Data link and physical are the main. In the physical you will see physical media attachment, physical media dependent. This is covers under ISO 11898-2, and the data link, logic control is there, logic preparations, these programming things are included in the data link, media access control and physical coding. Okay, these three parameters covers under, means this data link covers under ISO 11898-1. Now benefits of the CAN bus. The first is simple and low cost. Okay, as material required is less as compared to complex wiring, so the cost is low. ECUs communicate via signal CAN system instead of via direct complex analog signal line, reducing error, weight and wiring and cost. It reduces wiring, it reduces cost, weight is also reduces and error also reduces because large wire are not there. Here you can see in the first figure, you can see this is the previous method where large wire are used. Large wire means every function has their separate wires, and now you can see only single cable is going for controlling all the functions, right? Only by using these two wires. These are interconnected. Okay, and you can see this structure which is crossed by a red mark. So here different wire are used for interconnecting the ECU to sub ECU. Now in the second easy access, the CAN bus provides one point of entry to communicate with all network ECUs. Okay, now near about more than 70 ECUs are there, right? So for controlling them, the CAN bus provides only one point of contact, only one point of entry, not 3, 4, 5, 6, 10 wires. Only 2 wires are used, right? And now extremely robust. The system is robust towards electric disturbances and electromagnetic interference, as I told you, because mostly large wire are used, then electromagnetic interference created and it will damage data or interruption of the signal will happen due to that, right? So it's efficient. CAN frames are prioritized by ID so that top priority data gets immediate bus access. It means every what you can see, CAN frames are prioritized by IDs, means every feature has specific ID, specific and different IDs for identification purpose, for communicating purpose. As like in human beings, you can see everyone has their names for identification purpose, right? So here different IDs are assigned to different ECUs so that they when they pass the signal, so it can accepted by exact the same ID, right? So data get immediate bus access without causing interruption of the other frames or CAN error, right? It reduces error also. Now in the next slide we will see the history of the CAN bus. Pre-CAN means the previously wires or previous CAN car ECUs rely on complex point-to-point wiring. Now in 1986, Bosch developed the CAN protocol as solution. In 1991, Bosch published CAN 2.0, CAN 2.0A, which is capable for 11 bit, and 2.0B capable for 29 bit. In 1993, CAN is adopted as international standard ISO 11898, and in 2003 ISO 11898 becomes standard series, and in 2012 Bosch released the CAN FD 1.2 flexible data rate. As the versions are updated, they are updating the speed of transmitting speed of the signals, and errorless property they have added. And in 2015 the CAN FD protocol is standardized ISO 11898-1, and in 2016 the physical CAN layer for data rate up to 5 megabytes per second. Now here you can observe speed has increased, right? Standardized in ISO 11898-2. Now next, what is CAN frame? Okay, so you have heard in this our conversation what is actually the frame. We have heard this word. Communication over the CAN bus is done via CAN frames, right? Means the passing signals we can pass through this by using programming codes. Embedded language are used for programming these signals. So here you can see this is the one frame. This starts from here and ends from here. When signal is once the signal received, so identifying the signal, which signal is there, what to give output according to that signal, and decode that signal. Whether error is there, so read what you can say, identify that error and analysis of that error. So these type of functions are made by using this frame. Okay, this is the CAN frame. Just like one signal received here, it is identified, which is for XYZ feature, so it is decoded and then the action is taken, and here you can see the acknowledgement and end of the frame, right? Now in the next slide, what is CAN frame? CAN frame is explained in detail here. SOF, the start of the frame is dominant to 0 to tell the other nodes that a CAN node intend to talk, right? And ID, the ID is the frame identifier. Lower value have higher priority. RTR, the remote transmission request, indicates whether a node sends data or request dedicated to data from another node. And control, the control contain the identifier extension bit, which is the dominant 0 for 11 bit. It also contains the 4 bit data length code DLC. These are some features. Actually I can only explain this theoretical part for this frame because this is related to programming part. We just have to keep in mind this is the frame, and this by using program this process is proceed like this. Okay, so we'll move to the next frame. How to log CAN bus data. What is meant by this how to log CAN bus data? Means how to connect these CAN cables to the ECU. To connect CAN logger to your CAN bus using an adapter cable. Cables are used to log the CAN buses to the ECU. Now car, in the most car you simply use an OBD2 adapter. OBD2 is one type of connector or adapter to connect. In most car this will let you log raw CAN data as well as perform request. In heavy duty vehicles, to log J1939 standard are used. From means heavy trucks, the standard J1939 is used for plugging the data cable to ECU. Which type of connector to be used for plugging to ECU, right? For heavy industry J1939 is used, and for the cars OBD, onboard this diagnostic disconnector are used. CAN open, for CAN open logging you can often directly use this connector. DB9 connector also used to connect the ECU. It is one of the type of to communicate with the ECU, to connect from ECU to cable, right? Now in the next slide, J1939 protocol for heavy duty. Now ECU J1939 is a standard in vehicle network for heavy duty vehicles, right? So just different parameter, RPMs, temperature, speeds, different parameter all controlled and designed by using J1939 standard SAE, right? And for the cars, OBD2 standards are used for selection of the ECUs, connectors and these cables. Okay, is a self-diagnostic and reporting capability that example mechanics use to identify car issues. And then third one is can open. Can open is widely used in embedded control application, just like making industrial automation. If you wanted to do the programs of the robotics, so can open these are used. And now the last one, can FD. Can FD is a high CAN bus with flexible data rate. CAN FD is an extension of the classical CAN data. Okay, so this is the most what we can say latest version of the CAN FD, which is the fast transmitting signal cable. Okay, now next ECU part and CAN high and CAN low wire. Now from this diagram you will get deep idea about the how they are connecting the how they are doing the routing of the wire, 3D routing, or you can see in practical routing what it's done actually. Here you can see, just assume this as a main ECU. From this main ECU only two wires are connected, and then from here these two wires are distributed throughout the network, right? And by using these two wires are connected here also, and the same two wires are connected here to the backlight, right? And then here this is to the ECU, this connected to the AC, upper roof ECU we can say, right? This is connected to this or the bumpers or the brake system, right? So just like only these two wires are interconnected throughout the car network, right? And the communication is done by this what you can say CAN low and CAN high signals. And one main thing that is, I think how much volt, I think 5 volt. By adding both the CAN high CAN low, it will be I think 5 volt. It should be 5 volt, right? CAN difference, this is without CAN system previously we were using, and this is right now. These are different features of the car which is controlled by this single CAN cable, and these are the previously complex wiring method of the car wiring system. Next window, components work together to make communication happen. Okay, so message sending, this is the communication is done in this way: message sending, message receiving and error checking. In message sending, when a node needs to be send information, means any feature sends in information, it creates a message, it creates a signal and put it on the bus. For example, a sensor might send a message about the temperature to the control unit, means temperature sensor from the coolant or from the engine is sending some signal of the temperature data to the control unit. Now the message receiving, all nodes connected to the bus receive the message, but only the intended recipients process the information. The identifier in the message helps each node decide if the message is relevant to them, right? So, and then error checking, CAN bus has built-in error checking to ensure that the messages are transmitted accurately. If the message is corrupted, is ignored and resent. Means if any message is sent from sub ECU to main ECU, so it is received or not, whether it is damaged, so they self check the signals whether received or not. If it is not received, so it self take the action, right? Is there any damage or not? Now the next window, components work together to make communication happen. This is just the some of the representation. This is the main ECU, and this CAN high and CAN low are connected through one of the connector, diagnostic connector to this ECU. And the next, other vehicle devices. These are all the other vehicle devices, just like this is the steering, this is I think airbag system, and this will be the one of the feature, right? Next, auto device and display. This all data, some of data display is used for the output purpose, right? Just like if any temperature is going to increase in the engine, so ECU will send some signal to on the display. We'll see how much the temperature is there at engine, whether it is at this level or it is normal or okay. Now in the second representation you can see CAN devices. This is sub devices 1, 2, 3, 4 they have shown, and here the resistance is used at both the end, 120 ohm here and 120 ohm here. The purpose of providing this resistance 120 ohm is that to what you can say, if any extra signal is there, they will reduce that extra signal. Then if signal means it protects the signal, main signal, it's protected by this resistor, right, to avoid the damages signal. Now network distance, this is the node distance, this is node distance, this is the network distance. Now to the next slide, here you can see the car. On this they have shown some ECU, ECU1, ECU2, ECU3 and ECU4, how they are interconnected. For each sub ECU they have CAN controller and CAN transceiver, means one signal, they received a signal in it, so they can receive the signal, decode that, read the signal, and they perform the action. This is the bidirectional communication, means from sub ECU to ECU or ECU to sub ECU, like that. Now in this diagram representation you can see CAN high connection, CAN low connection, and between R1 120 ohm resistor is connected here. As the standard, they have at both ends of the frame two resistors are there. Here is the one resistor and here is the second resistor. At both the ends have 120 ohm resistor. Now engine control unit, this is how the engine control unit is connected to this, only both this wire, CAN low and CAN high, right? If engine control unit, just assume a signal like what we can take for igniting that coil, heat coil is there, temperature sensor are there, so this data is gathered from this control engine to this ECU, okay, means this is transfer from here. And automatic transmission control unit connected like this. All features, airbag control unit, combination of devices, OBD2 diagnostic connector, okay. Now here the main connector is combined here, OBD2 diagnostic connector, combination of devices, means from this OBD2 diagnostic connector it is connected to the ECU. Just assume here the ECU is connected and this is the main connector which is connected to the ECU, and now these all the features are interconnected like this, okay. In the next window we'll see the powertrain CAN bus, fast bus, which allows information to be transmitted at okay, some data is hidden, okay, actually one, okay, this got missed here, so okay, now okay, over here we were actually we were here the powertrain CAN bus, means here you can see these are some features of the car which require instant input with high speed rate, okay, because they are critical parts of the car. Here you can see powertrain CAN bus, engine ECU, electronic control unit, airbag control unit, ABS control unit, electric power steering control unit of fuel injection system, central mounting unit. These are main features, so they require instant reaction or instant supply. So that's why the powertrain CAN bus fast use, which allows information to transmitted at speed of up to 500 kilobytes per second. 500 kilobytes per second capability of cable used of this CAN, right? So they can provide instant input and outputs. It serves for communication between the control unit on the engine and transmission line and can be in the dominant state when the ignition is on. When ignition switch is on, so at right providing the fast signal, that's why they have used 500 kilobytes per second property of cable. In the next window we'll see Now in this case they have used 100 kilobytes per second data cable CAN bus can provide, just like comfort system. This is the comfort system. This not required instant input at instant input or high speed connections. So system CAN bus slow bus. This is slow bus called because 100 kilobyte per second speed is there, which allows the transmission of the information at speed of up to 100 kilobyte per second, means less speed, right? So what things are included in that comfort system CAN bus? Instrument cluster, electronic door unit, parking system, electronic control unit, electronic control units for comfort system, tire pressure control, right? In the next window, so apart from that, both the high speed and medium speed, this is one of the other services, just like CAN bus information and command system slow bus, which allows information to transmitted at speed of up to 100 kilobyte per second. It serves for communication between various services system, just like navigation system of car, information system, audio system of the car. These are some basic types. Now connecting to the onboard diagnostic connector. So as I told you, for connecting ECU there is a required connector. This type of connector they have used. This is one of the type of the connector, and these are the pins of that connector, 1 2 3 4 up to 16 pins. So for that pin nomenclature is mentioned here. One for one pin manufacture feature means manufacturer, it will be used for XYZ purpose, but second pin is for J1850 bus, third pin is for XYZ any feature we can connect, and fourth pin general body of the vehicle, fifth pin is for general signal. And here the CAN cable has two signal only, high and low. So in the sixth pin CAN high wire is connected, and in the you can see CAN low, CAN J2234 low, CAN low is connected at the 1/4 pin of this connector. Okay, so like this, these connectors are used, and we are having specific format according to their pin assignments. Now the CAN bus communication model with ECU model, ECU nodes in the vehicle. Now you can see this is the main cable which is twisted here, CAN high and CAN low, having the resistance at both the ends, starting and ending. And now as it is connected to H sub ECU, these are the sub ECU. First is engine control unit, CAN controller and CAN transceiver, means that sub ECU plays to both the feature CAN controller and CAN transceiver for communication between ECU, right? So these are for suspension control unit, these are for speed control ECU, and this is for airbag control unit, and this is for ABS control unit. The CAN bus spoofing meshes attack model with ECU node in the vehicle. So this is just deep diagrammatic representation of the signal, just like you will get deep idea about that right now. Okay, so in the first block you can see real ECU 1 having ID 0001. Okay, so this ID is assigned to this first ECU. Okay, now you can see second, for second it is assigned 0010, and third one assigned ID 0011, right? Now what the signal is created for now, ECU1 sends real logic message 0001, right? Means now signal is created from any of the XYZ sensor, any of the XYZ function. Just take an example of temperature sensor from engine control unit. So it is created 0001 signal, right? Now it should be accepted only by which signal? Here is 0010 and here is 0011, right? So this device will not accept which is ID 0011 and this ID 0010. It won't accept this signal, right? What it says, receive logical when it this ID what you can say real logic message created one message, right? So these signals are transmitted to each and every functions, just like this ECU. What it says, ECU3 says the signal is not belongs to me, so it rejected. And he also says that ECU2 sends proofs logical message, this ID is not belongs to this, right? Now in the next window, yeah, so this is all about this. I have this 27 pages of PPT on the CAN cable or CAN bus. You will get how, if you wanted to download this PPT, you will get the link in the video description. You can download directly for your presentation, for understanding and study purpose. So hope the some content I have delivered today to you. One request is there, please kindly subscribe to my channel. It will motivate more to make video on this channel regarding this topic. Okay, so thank you very much friend for watching this video.